previously, we are Camellia Cafe. Differential is necessary when the vehicle turns, making the wheel that is traveling around the outside of the turning curve roll farther and faster than the other. Central differential is also necessary for a four-wheel drive car when turning on dry pavement, allowing front wheels to rotate at a different speed than the rear wheels.
Either of rear wheels is wheel spin, the other will never spin, the same as the front wheels. Thus, when unlocking the differential, the car can't run out of the rough area. Any one of wheels is wheel spin, other wheels will never spin. Thus, when unlocking the front, rear and central differential, the car can't run out of the rough area.
A differential locking is a variation on the standard automotive differential. It provides increased traction compared to a standard, or open differential by restricting each of the two wheels on an axle to the same rotational speed without regard to available traction or differences in resistance seen at each wheel. A differential locking is designed to overcome the chief limitation of a standard open differential by essentially locking both wheels on an axle together, as if on a common shaft. This forces both wheels to turn in unison, regardless of the traction available to either wheel individually. When the differential is unlocked, it allows each wheel to rotate at different speeds, thus avoiding tire scuffing. An unlocked differential always provides the same torque, or called rotational force, to each of the two wheels on that axle. So although the wheels can rotate at different speeds, they apply the same rotational force, even if one is entirely stationary and the other spinning. A differential locking forces both left and right wheels on the same axle to rotate at the same speed under nearly all circumstances, without regard to tractional differences seen at either wheel. Therefore, each wheel can apply as much rotational force as the traction under it will allow, and the torques on each side shaft will be unequal. A differential locking can provide a significant traction advantage over an open differential, but only when the traction under each wheel differs significantly. All the above apply to central differential, as well as to those in each axle. Full-time four-wheel drive vehicles have three differentials, one in each axle, and a central one between the front and rear. Central differential locking enhances the mobility of an all-wheels drive car in rough road. In an all-wheels drive car, front or rear differential locking will lose its potential function if without central differential locking. The same as that, if only using central differential locking without front nor rear differential locking, the car will still have wheel spin. The power is transmitted to front and rear with 50% of each. When either wheel in front or either wheel in rear has wheel spin, the car can't move. Selectable lockers allow the driver to lock and unlock the differential at will from the driver's seat. This can be accomplished by many ways: compressed air, cable-operated mechanism, electronic solenoids, and electromagnetics. Full-time all-wheels drive systems drive both front and rear axles at all times via a center, or called interaxle differential. The torque split of that differential may be fixed or variable, depending on the type of center differential. This system can be used on any surface at any speed. Part-time all-wheels drive systems require driver intervention to couple and decouple the secondary axle from the primarily driven axle, and these systems do not have a center differential. Automatic lockers lock and unlock automatically with no direct input from the driver. Engine power is always transmitted to both wheels, regardless of traction conditions, and will unlock only when one wheel is required to spin faster than the other during cornering. On-demand all-wheels drive systems drive the secondary axle via an active or passive coupling device or by an independently powered drive system. The standard notes that, in some cases, the secondary drive system may also provide the primary vehicle propulsion. On-demand systems function primarily with only one powered axle until torque is required by the second axle. At that point, either a passive or an active coupling sends torque to the secondary axle. Let me show how differential lockings function. Please watch and think by yourselves.
Let's unlock all differentials. Then locking front and rear differentials, and keep central differential unlocking. This time, locking all differentials. Then, locking central differential, and then locking front and rear differentials. Welcome to Camellia Cafe. More interesting products and learnings, please visit www.camellia.xin. Your precious ideas will improve our products and service greatly.